Here we'll be showing the experiment that StressNet uses to collect data. In this experiment, we collect both thermal recordings of the patient's face as well as their ECG signal. Over here we have our thermal camera, which is responsible for thermally recording the patient's face. Over here we have an Arduino, which is used to sync up the thermal recording as well as the ECG recording. And this blue device here is the BioPack, which is actually responsible for collecting the patient's ECG recording. Over here we also have a headrest, which the patient places their head onto in order to remain stationary in the frame. And as you can see over here, we have various electrodes placed along the patient's wrist as well as their ankles, and this is used to actually record their ECG signal. And this bucket over here is filled with ice water, and once the experiment begins, the patient will place their hand into the water, which induces a stressful state and will induce stress that we can actually measure in the patient. And over here, we'll be showing how we can actually trigger the experiment and the recordings.
So here's the Arduino script that allows the thermal camera and the BioPack to communicate and trigger at the same time. So you can upload the Arduino script. And once it's done uploading, X this out. You can start the BioPack, and it will be triggered by MATLAB over here, which is run MATLAB. That allows them to trigger at the same time. So the thermal video and the ECG data are now synced.
And so now that the recordings have been synced and started, the patient will now keep his hand in the ice water for 2 minutes while being recorded, at which point the experiment will conclude. And finally, here we have an example of a thermal video from our dataset that the model has already evaluated. In this case, the model is indicating every 15 frames whether or not it thinks that the patient is currently under stress. A 1 represents a stressed state, while a 0 represents a non-stressed state. Since this video recording is of a patient currently under stress, the model is accurately predicting a stressed state of 1 most of the time.